Hi everyone, this is Bill from AT Makers. For those of you who were expecting me to be live here on YouTube, I was, and it didn't go live, and I'm kind of bitter about it. So I went back to Facebook and I did a live chat there, and I recorded it, and I'm going to post it immediately after this. I will tell you, I'm going to have a hard time doing Facebook or YouTube live again because that was insanely irritating to have a little flashing button that says you are live and it didn't go live. To this day, I don't know what button I didn't hit. So I may be doing these training videos for PCB boards on Facebook and then posting them immediately after to YouTube. I know some of you will hate that, but it might be what I have to do because I'm not doing that again. So sorry about that, and here is the chat we had on Facebook. All right, we have a working switchboard. Yay! This is really cool. It is a long time coming. For John and I, it's been a ton of work. For those of you waiting for it, it's been a ton of patience. So thank you very much for that. John, thank you for the help on this. So for those of you who do not know what this is about, this board right here is actually came out of the conversation with Jim Lubin when we made him his switch router. If you guys remember, we made a device where he could control 3 different devices with his sip and puff. He could pass them through. And if you remember, let me show you my screen here for a second. If you remember, Jim's switch looked something like this. All right, so there you go. All right, so Jim's switch looked like this big mess right here on the left. It has a feather, which this one will have a feather as well. It had a current sensor. It had 4 relays, and then a bunch of discrete components. So 4 transistors, 4 relays, 4 diodes. It's a whole bunch of garbage. Headers to screw things into, and then all the wiring between the relays as well. And this was a mess. This was a total mess. Jim will tell you it was a mess because it failed him. It failed on the way out when TSA was rough opening it up and pulling at the wires, and we never quite got it back to a reasonable state, and so it failed again after I left Seattle about a week in. Hold on. Excuse me. Jonathan, you were smart not to come over here. I think I'm getting a cold. So Max was good not to be around me today. Those of you who don't know, there is a conference in Orlando. Max Lasco's there for SMA conference, and he was going to go boating with us today, but it's probably good that he didn't. So let's talk a little bit about this. This was made in China. It was made by PCBWay, not just the printed circuit board, but the entire circuit. So actually, let me get you one that's not hooked up so you can see exactly what it looks like. It's packed in this anti-static bag, and I've tested all of them. I had 15 of them made. Most of them passed, and I think I know why the ones that failed. So let's go ahead and give you guys a good little walkthrough here. All right. And yes, I did this all in the other video. We'll just do it again. Screw it. So right here, you'll see there are actually 5 relays on this board. These are latching relays. What that means is that they don't take any current to hold on. You send current through them to move them over, and then you send current through them to move them back. That way, if they're all on, they're not drawing a ton of current. You just turn them on one at a time. We wrote a library to make that happen. In the center here is a port expander. This is a I2C device. What that means for most people is just that it doesn't require a lot of pins on the controller. It actually will, it takes just the shared SDA and SCL pins, from the I2C bus. It needs power and ground, and that's it. And then these two are actually really interesting chips. These are actually relay driver chips. So inside of these chips are all of those discrete components that you heard me talk about before, the resistors, the transistors, the diodes. Everything that you need is inside of these chips. Each one will drive 7 relays, 7 coils. We needed a total of 10 coils because they're latching relays. And so we have 2 of those. We have a current sensor, which is over here, which was also on Jim's board that we made him. So basically you can run one switch, one line into the current sensor and use it let it snoop. So it can snoop on one channel. So if your SIP line is coming in and you want a long SIP to mean switch which direction you're going, you can do that. So that's on this board as well. And then the only other things here are a power relay, or power LED, which actually is an issue, a reset button, and a couple other things over here that are more convenient. So in the center, we had 6 extra ports from this port expander. We thought somebody might want to use it. We went ahead and exposed them. We also have the 2 interrupt pins from this port expander. We exposed those as well. This strip here and this strip here are for the feather. So if you have a feather, I don't actually have one with me, but I have a feather wing here so you can kind of see how it would go on top. But you need to put a microcontroller of some sort on this in order to be able to control it, just like the one we made for Jim. So this entire board was made by PCBWay, not just the printed circuit board. They also did all of the assembly. Okay, so they put these chips on for us. They put the relays on for us. The only thing we didn't have them do was to put the screw terminals on for us and the headers in the middle. And the reason for that is that we may configure this differently for different people. In some cases, we might solder the wires directly to the outside. In some cases, we might want female headers in here for the feather. Sometimes we'll want stacking headers. Sometimes we want male headers. And these are easy to do. These are through-hole components. We can pop this on and then just solder it into the bottom. We can all do that without a lot of stress. Whereas these tiny little pins right here are definitely going to be a challenge for many folks to solder. I did get some boards that were not assembled, and I got some components as well, because I'd actually like to be able to do this. Since I ordered these, I actually started to believe I can probably do this, and I want to try it. But I wouldn't want to have to do it for every person that needs one of these boards. And the reason people need one of these boards is worth talking about. Hi, Eric. Eric from PCBWay is on. So good to see you. Sorry I'm late. I'm redoing this. The entire thing I did over on YouTube was thrown away. Let's go ahead and talk about why people would want to use this board. So the first thing you might notice is it's got 5 relays. That actually lets it completely eliminate or replace the board that I made for Max and Ella. So if you remember on the boards for Max and Ella, I can show you a picture of that here as well. I'm pretty sure. Oh, you can't see. Sorry. So, you guys remember Max and Ella were both using, let me see, relay Ella. There's got to be a picture in here somewhere of it. Anyways, I'll just talk you through it. We had a board that had 3 relays that went to forward, left, and right, and that lets Ella control her power chair. Max also has SMA as a power chair, actually has 4 relays. In theory, he could control left, right, forward, and back, but we don't have any way for him to trigger back as far as switches go. So 4 of these relays are exactly what Max and Ella have in theirs. So we could replace that. We added a 5th because if you want to replace a joystick, if you look at the connectors on a power chair or just a joystick for a game, you generally get left, right, up and down, and activate. And so we added a fifth one here to give you the activate. As you'll see in a minute, there's lots of other ways to use this. In Jim's case, the way we used it we actually route current through one relay into the next and then out. And what that lets us do is it gives us 3 different outputs for that signal. And because we ran out both the both sets of on these relays, they are dual pole, double throw. What that means is that it can actually control both the positive and negative side of the switches, and pass them both through. So you very quickly get the ability. Actually, I have a drawing of this on the back of this. You very quickly have the ability to send a signal through one relay and then through another relay, and you have 3 different places that signal can be sent to. So we did that here. Because of the way that works, if you want to use this as a switch router, I'm not going to call it a switcher because it acts differently than R.J. Cooper's switcher. It does solve some of the same problems. But you actually get the number of relays plus 1 output. So if you want a single circuit, you can actually send it to any one of 6 different outputs. If you want to do 2 different signals, like sip and puff, you'd actually get 3 outputs and you have a spare relay. So you have a lot of different options on how you would use this to route signals around, or to use them as basic switches. So hopefully that gives you an idea of kind of what this thing does. If you guys have questions on that, let me know. I can actually see your comments, which is great. But this isn't the whole point of this video, right? This is kind of a small part of this video. I will show you that I did get the tester for it working just while we're on this one. There are a couple problems with this board. The first is either our fault or PCB ways. I haven't figured it out yet. I don't think it's going to end up being PCB ways, but you might notice this LED is just insanely bright. And the reason is there's no current limiting resistor on it. So either when John and I designed this, we were expecting to have an LED with a resistor built in, and we didn't specify that. Or we did specify that, and PCBWay swapped it out for another part, which I find unlikely. They did send us a list of parts they were swapping, but I don't remember this one. Or this actually does have a current limiting resistor, and it is just way too small a resistance because that is hot, and that is way too bright for a power indicator. So I'm going to take this off. I'm going to take this off of all of them because it's just draining power, and it's not hard to remove. So I'll remove that. The other thing is this tester, and I think I showed this before. I made a tester following Lamore Fried's instructions using pogo pins. I used a teensy board over here, which has just a ton. I'm going to say buttload, but an absolute ton of GPIO pins. And you need that because you actually need to connect it up to every common, normally open, and normally closed terminal, as well as the SCL, SDA, power, ground, the current sensor, and these extra pins. If you want to test them all, you got to connect them all. So I actually used all but 3 of the Teensy's GPIO pins. And I did show this on the other video, but I'll do it again. Probably have to stop saying that now. But let me clear this output, change to the screen, and let me switch cameras. Okay. So if I actually hit this little button here on the side, it will actually run all the tests, and it passed all the tests. You can see right here. It tests each of the 5 relays. I'm not testing the current sensor yet or the extra pins yet. I wanted to make sure we had a working product before I got too picky. But it actually walks through every one, turns on a pull-up resistor, tries to send zeros through, turns on a pull-down resistor, sends high through, makes sure that it works on every one of them. I'll probably also write a script that actually runs through every possible combination of the 5. It's only 64 combinations. It wouldn't take that long, and that would actually help us with making sure that we don't have current draws and things like that. But this worked great. Again, I have LED problems. This green LED should be lighting up when it passes, but I think I put it in backwards. So I have a little bit of cleanup to do here. But I did get a few that failed. I think I know why. And so we won't really get into that. That's very much into the weeds here. I do want to talk a little bit about, let's see. So John says LED is rated 20 milliamp, 3.3 volts, so 66 milliwatts. Yeah, and John, there you go. Can you look up and see if we meant to leave off a resistor, or did we think it was going to have one internal or not? Either way, I don't think we can leave it the way it is. So let's talk a little bit, though, about PCBs. This isn't about the relay wing. It's not about the switchboard. Although I'm really excited about the switchboard. It's going to allow us to let STEM programs who can't quite do the level of wiring necessary to do Ella's chair or Jim's switch router, it's going to let them do these projects because it's going to take a one-time effort of making this board and $35, right? It's going to cost us about $35 to send a board plus shipping. And we'll do something where we have people sponsor them, right? Sponsor a board, something like that. I think I said this earlier, but I don't remember which went on which stream. I would much rather have these being made by either an AT company like Glenn Dobbs or Jonathan Eckrick, or an Adafruit. If there are non-AT uses for this, I'd much rather have these be available in somebody where they have better scale, better margins, lower prices. But in the absence of that, I'll stock them and we'll send them out from here. It's a really powerful tool. So this is also the introduction. This video is also supposed to be the introduction for this series of videos about PCBs. Why AT would want to make PCB boards, why I think it's important, why it's something that I don't think we should leave on the table. And I'm going to go through kind of an example real quick of something really simple that doesn't work without a PCB board. Wrong camera, sorry. One sec. All right, so long ago and far away, if you guys remember, I actually made this circuit, and I shared this with you guys. This is a circuit that it's very simple. It's got a battery, a couple of 3.5 millimeter jacks. It's got a transistor, a relay, a resistor, and it's actually missing a diode that should have on it. And it has a switch. So I've made one of these. I've shown this at AT conferences inside of Altoids tins. What it does is it allows you to use something like a proximity switch, like a honeybee or a candy corn or an infrared switch, a scatter switch, or anything that's electronic has trouble with things that are motorized. So bubble blowers, motorized trains, anything that has an inductive load to it. And so this is a very simple circuit that just says, all right, when you activate your high-tech switch, activate the relay, which then sends the message to the device. What it does is it isolates the high-end expensive switch from the inductive load. Make sure it doesn't get broken, and also just make sure it works. So it's inexpensive. It doesn't cost much to make, but you can't quite have somebody wire this up and have it in an Altoids tin for the life of the person using that device, right? But if we put this onto a PCB board, all through hole, nothing fancy here. Anybody could pop these in, solder them onto the back. We can make a 3D printed case that fits them perfectly. And we can actually have something that long-term will support somebody like Julie, right? Julie Marzano in her business and her practice, where she wants to introduce maybe a high-tech switch. The first thing you want to use is something fun. you want a bubble blower, you want a toy, and it doesn't work. This would be a very inexpensive part. It would be $5 in parts plus a $1 or $2 PCB board. We should be able to make this. But we can't do it if we're wiring it all by hand. We can't make it stable. We can't make it supportable. And we can't expect teens to make this every time when we can make it ourselves. Okay? Noah says, Mei Ling says, what language are you speaking? Diode. Come on, Mei Ling. Noah says, engineer East. That's correct. Mei Ling, you will not get a degree. Not a chance. But you'll learn something, which is good. Okay? In fact, you should have just learned something about a switch isolator. There's another important example. So the first video I'm going to make is going to walk us through making that isolator. It should be easy. I'll do it from scratch. I'll tell you that I cheated. I already have an idea of how I'm going to do it. On the second one, I'm going to show something that we can't possibly do without using a circuit board, without using a printed circuit board. I'll go back to the overhead for a second and show you. One of the things that this board will do is that it will emulate this. It will emulate this, right? So it will emulate a basic 4-switch joystick. Forward, back, left, and right. Inside of this, if you look carefully, there are just 4 switches, right? So it actually has exactly the same thing in it as the relay, right? These are actually very similar to the relay switches. And when you move this, it will just send left, right, up, and down. If you do up and left, it will actually send both up and left. It'll close both of those circuits, right? So you can get basically 8 points of the circle plus the center, which is inactive. This can totally do that, and you can completely make this like I did for Ella and Max. We can totally make this with through-hole components without any printed circuit boards, and it would totally work. The flip side is you can't do that with this, right? So this is a joystick that doesn't just go up and down and left and right. It will go a little bit up and a little bit down, a little bit right, a lot right. It's an analog joystick that actually lets you change differing degrees of how far forward or back you're going. And so if you look inside of here, I'll just bring it up. There actually is a little potentiometer in here, a little resistor that changes when this moves. And there's another one on this side for left and right. And these 2 values are actually what the joystick sends to the controller, to the chair. These are dirt cheap. They're, I don't know, $1, maybe $2. But if you want to emulate them, you cannot buy something that is through-hole. You can't buy something big that's easy to solder. They only come in tiny little chips that look like these, okay? But you can buy them, and they're a couple of bucks, right? It's $1 a piece. You'd need 2 to do a joystick. So you actually could make in a PCB board, you can make something that has 2 of these on it, and it can be a virtual analog joystick. That's cool. That means we can't just do, like this will work on a power chair, right? Forward, back, left, and right will work on a power chair. But if you want to fly a drone, this isn't going to work, right? This isn't going to give you enough control to do it. You need to be able to move a little bit forward, a little bit back. And in fact, a lot of people who use power chairs will tell you, long term, you want that on your power chair as well. So this is great when you've got nothing. But the next logical step would be to emulate forward, back, left, and right a little bit. And the breakout boxes for power chairs give you the option, right? They give you the option of either doing a digital switch like this or an analog switch like this. But to do this, somebody in our team needs to know how to make a PCB. Not everybody, right? Noah needs to. I need to. Brady needs to. Right? There's probably 10 of us who need to get to the point where we can crank one of these out, send it off to PCBWay or Osh Park. I'm not trying to shill PCBWay. I will tell you, so far their stuff has been solid and cheap and fast, which is good. If I can get all 3, that's awesome. But regardless of which vendor you go to, we should be able to make these things and have them in a form that the rest of us can use. Like if I shipped this board to Steve Bowman's team in Orlando, they could wire this up to a power chair. There's no doubt about that. Could they make it from scratch? Probably not. Steve could. I have no doubt of that. But his team would have a challenge making this from scratch. So that is something that is totally impossible to do without us making some PCBs. And then the last thing will probably go to something that requires us to not even do the assembly ourselves. So I'll probably do 3 videos, maybe working up to something like this and walk through the process of having offshore assembly done. If anybody has something that you'd like me to use on the 3rd video, let me know. I'll be happy to take direction. As you can see, some of these things are specifically meant to work with some of the Adafruit components. So Adafruit folks, who I see you on here, by all means, if you've got a starting point and you want me to make something that will work with your stuff, let me know. This actually, interestingly, will actually go right there and add 5 relays to your Cricut board, which is kind of cool. I'll probably talk to that at some point. But let's see if we have any questions on here. So Mailing says you can put candy corn on the board. Think you're being a smart ass. Yes, I have made a printed circuit board that has a capacitive touch switch on it. So while you're being a smart ass, yes, you can put a candy corn on the board. In fact, to be fair, these right here work exactly like a candy corn. These are capacitive touch buttons on the Cricut, and I could certainly emulate that on a circuit board that we make. Hi, Barbara. We're talking about printed circuit boards and the fact that this relay board, the switchboard, finally came in and is ready to go to work on a few different projects. Chris Young, analog joysticks are often referred to as proportional as well. Okay, I agree. I think that's a good point for those of you who aren't technical. But yeah, it means that the farther you throw it forward, the more forward it's going to be. There's pros and cons to both of these, right? In fact, I have another one within arm's reach, I think. I did, which is actually a little bit different. Give me a second. I just had it. Oh, it's irritating. So I have another joystick that was within reach and is no longer within reach. That, yeah, I don't know where it went. I have another joystick that actually, unlike the analog joystick and unlike the digital joystick, I don't even know if you guys can see me anymore. There you go. It actually literally only lets you go. Here, I can show you on this one. It only lets you go forward, back, left, or right. You can't go forward and left. And it's just literally got a mechanism in it to only let you go one at a time. And I just had it here, and it's going to be right as soon as I hang up. It's going to jump up and bite me. But yes, so there are multiple ways to do that. What other questions have we got here? Catching up. What design tool are you using? I used Eagle. I can kind of show it to you guys if you want. So I used Eagle CAD. There's pros and cons to that too. And this is more John than me, at least on the schematic side. It's almost 100% John. I helped with the actual board layout a little bit. And then I made a bunch of boards since then, kind of because I really enjoy it. It's almost therapeutic. This is kind of what the board looks like before you send it. This is a complicated board. This is not a simple board. We're not going to start with this one. But you design it in Eagle or KiCad. I'm very happy to work in KiCad if somebody wants to give me a training or two. I'm not tied to any of these tools or vendors. But I did learn Eagle watching Adafruit's videos. Lamore makes some great videos. So that's kind of what I learned. And it's probably what I will show unless somebody gives me a really good reason not to. Let's see what else in here. So, okay, people are good with EagleCAD. That's good. To kind of go through the process for those of you who are less technical like May, the idea basically is you draw out your circuit. So this is the port expander. Each of these two is the relay drivers. Each of these things that says K1, K2, K3 is one of the relays. There's some other stuff in here that's not very important. This is the current sensor. Once you lay out the circuit that you want to make, you then go through and make a board where you place all these things on there, and it kind of makes sure you don't screw up. It's the best I can describe it in a minute or two. We'll walk through the process of making it. We will obviously start with something with many, many fewer components than that and make something simple. But I'll go ahead and send it through the process and get it printed at PCB Way. They're the ones doing the contest. They're the ones I'm working with for the judging of the contest. So Jake McIver just says Eagle has a neat integration with Fusion for designing 3D enclosures. You're right. In fact, I will bring that up. I can show you that because I was just making an enclosure. And we happen to have like the guy here. So Noah and Pedro are the guys for making enclosures from PCB boards. Here, sticking it. So yeah. So yep. So I did exactly that just the other day. Yes. So yeah, so it actually does let you start with your board. Let me turn these off. It lets you start with this board, which is the board I just showed you in Fusion, and then in our case we put a feather on top of it to make sure it fit. Put an OLED wing on top of that, and we were building a case around it, and all the holes are going to line up, and it's going to be awesome. So yes, it does give you a really good integration to do that, even on custom boards. It does a very good job. So yes, we can do that. That might be the 5th video. I don't know. Maybe we'll have Noah do that video at the end. He can do it for his Wednesday show. I'm sure he wouldn't mind, right? Right? You'll do that. So way ahead of me. I have yet to get Eagle the few. Oh. So as long as you don't want everything coming in flat and then you adding the elevations, adding the heights, it comes through just fine. Why did you only do the 15 boards just for the test? Well, 2 reasons, really. It's a great question, Ann. Why did I only do the 15 boards? I only have a current demand for about 5 of them. They end up being about $40 a piece. They're really about $25 plus the shipping and some other cruft. But they are coming out to be about $40 a piece right now. I'd like to get that price down, but I also don't want to stock it. And one of the interesting things that I have learned about going to China for this is, and Eric can pipe up, he's on here. Once you've gotten through the first round of getting a PCB board and an assembly done, the second one goes very, very fast. So the truth is that if I needed another 15, I bet I could get them in about 10 days. I don't want to don't quote me on that, but I know I could get a new PCB in about 4 days, 3 or 4 days. So I don't see a need to stock them. The break point on pricing is there, but I mean, you're going to go from 40 to 35, and I don't know whether I have a demand. And the fact that, as you just mentioned, we don't know how solid this design is. We know we have at least one problem with this design, which is the ridiculously bright LED, which may have a resistor in it may not, but either way is absolutely not necessary to be giving off that much heat and light and bearing down batteries. So yeah, so that's why 15. I think it also lets me get the library down. I had to write a library I did. I wrote a library that wraps the Adafruit libraries to make this easier to use. I can show you that too, I think. Let's see. Yeah, so there's a switchboard library that basically gives you, this is Arduino. If Scott Shawcroft is there, I'll be happy to do it with you in Python. Probably need your help. But it basically gives you the ability to say set a relay, reset all of them, change the mode of the remaining pins, check the current sensor, and then if you give it a current limit, it'll actually tell you whether or not it's active. What I'd like to do there is to actually let this trigger an interrupt. I'm not entirely sure that I can, but it doesn't matter. But yeah, so I had to write there's a lot of things here. There are a lot of moving parts that I wanted to test on a smaller batch before I went and spent a couple $1,000s. It says, even Lamore from Adafruit only makes 100 of the new board when she intends to sell thousands. You need to see what's wrong with the first batch before you commit. She's an expert. Yep, absolutely true. I think 15 was probably the right number. I thought about going lower. The price went up, and I actually got at least one that I'm pretty sure failed. And I wanted to get enough to find out where it failed. If you just get two made, you may not see the errors until later. And these are errors that one of the things that I think John and I would both admit to. When you drop them, they break. No, they didn't break. Sorry. One of the things that I think John and I would both admit to is that while we can draw out schematics fairly well, and we can map them in Eagle better than I could a month ago, that's for sure. I don't think either of us are experts in designing it for manufacture. So knowing where to add tolerances, knowing what's problematic. I will tell you that right now, the biggest problem I have is that these two pins right here, which are the SDA and SCL pins, the tester doesn't connect well. It's on the inside. I think it might be rubbing against the relay. I probably should have made the tester against these, they're replicated over and they're wide open and they're easy to get to. So I will learn some things that are more about designing for testing and designing for reproducibility than they are about getting my idea on paper or into a board. So long answer. Sorry, Ann. A good question. All right, so the questions are piping down. So before I start dropping you guys off, heads up, I'm going to be dropping off in a minute, especially since I did this twice. I'm so irritated. I do want to show you guys that while I was waiting for this, so this, just as far as timing goes, if you finish a board design, like I did this tester, on a Monday night, you can have it on Friday. You might have it by Friday or the following Monday for 50 cents a board plus shipping. And that's nuts. So you guys know that's absolutely crazy. That means a total of less than $30 to have a board, to have 10 boards made in 4 days. Right? So getting the PCB boards back, it should, I mean, and it's low enough price that if I ended up throwing this away or making it a coaster, who's going to care? So making the PCB board and then getting the parts in China, having them make it, get back to us, send us photos of their work, have us check the work. We found an error in my instructions, so it's not Eric's fault, but this chip was actually sent to them upside down. The instructions were upside down. They then pulled them off of all 15 of them and put them back on correctly. And to give them credit at no cost to us, which was kind of crazy. I'm thrilled. I'm not complaining, but That took about 22 days. So they estimated 25, and we were a couple days early. So they estimated the 18th, and I got them today. So, yeah, so 22 or 23 days. They cost us a total with the board and the components and the assembly and the shipping came out to about $38 a board. Okay, that includes the stuff like this that we're going to solder on. They provided those separately in bags. Interestingly, it's kind of funny. I didn't tell John this yet, but we kept telling them, please provide the through-hole components like these separately in the box in bags. And what they actually sent us, and by the way, language is fun with this, but what they actually sent me was all the components in bags, and just for fun. And I don't know whether they were making fun of us or not. Whoops. They also sent us a bag of bags to bag each of the parts. So kind of cool. They sent us a bag of bags as well. So, but they sent us the ones for the screw down terminals. These are for the 2 screw terminals, and then the headers as well. So all of that came out to about $38 a piece. And no labor for us, right? So if you start looking at the labor and how long it would take you to make the board by hand, it's probably a lot cheaper to go this route. While I was waiting for this, I got bored and I got hooked on Eagle. And multiple times now I have stayed up all night because I realized I really, really wanted to make something. So I made this, which converts a Raspberry Pi to a Feather, which is great. It means you can pop an OLED display on your Raspberry Pi without having to buy a separate one. Once I did that, I realized I could do the same thing for like an Uno. So this actually is a shield wing. So it converts an Uno to a Feather shield. I made the tester for this one, and I have one more that isn't here in front of me. But I will tell you, it is addictive and fun to make this stuff. All right. If I'm not in a hurry, is there a cheaper shipping option? There is, but it's not much cheaper. So the shipping for 10 boards was $18 for 3-day shipping, which is kind of crazy. By the way, when I was at, so my AT Maker's address is at a UPS store. So I had all these things shipped to the UPS store. So when they got there, I turned to the guy at the UPS store who I know, and I said, can you do me a favor? Take a look at this address and tell me what would it cost me to ship it back 3-day. And it'd be $118. It was literally $100 more to ship it back to China on UPS than it was for them to ship it here on DHL. So, yes, there probably is a way that you can drop some cost off of that, Chris. I'm not sure that it's worth doing, especially given the fact that you might have an error and you could get you can get an extra round trip of errors in the time that you'd be waiting for those parts to get here. Hello, Antoinette. How are you? Deb Kerner. Hi, Deb. How are you? Glad everybody's here. I'm not going to do this on YouTube. For those of you who are YouTube fans, I will post this to YouTube later. As much as I would like to do it live there, that totally didn't work. And I'm not going to go through that frustration again. So we'll be doing it here on Facebook. Those of you who like that will be thrilled. And I will post the videos to YouTube afterwards, I promise. Okay? All right. I think we probably are out of questions. Does anybody have any final questions? Chris, Noah, anybody? Eric? Eric, do you have any comments from the PCB way side? By the way, Eric is a manager from PCB Way. He is the person who asked me to be the judge on their PCB contest that just started. And he was here. I'm not sure he's still here, but he was here watching the video, and he said hi. So I guess he's not here anymore. And I guess I'm going to let you guys go. I have a little bit of soldering to do. I have a little bit of I need to find out what's up with that LED, and I need to find out the one that really did fail. I want to find out why, but it might be tomorrow. Thank you, Noah, for the big. It is big progress, I think, right? When Lamore, you can tell Lamore. The last thing she said to me was, "You make the relay board, and if it works, we'll stock it." Well, we'll see how well it works. We'll see. But I really appreciate everything. We couldn't have done this without Adafruit. We're using their libraries as our base. We're using their videos to train ourselves how to do it. So tell Phil, when you talk to Phil, thank you. And I think we're gonna let it go. Bye, guys. If you have any more questions, follow up in the comments below, and I'll talk to y'all later.